Hi, welcome to the last session of the Open Security Summit December virtual edition. And what a great way to end. We have Clint Gibbler, who's going to do a presentation about what I think is a very exciting new sort of entrance on the whole static analysis sort of world. And if you know me, I'm very passionate about static analysis. It's all about graphs, and I've been in this industry for a while. And I've always been very frustrated on the lack of innovation on that part of the security world. And what I want to call out is that these guys are, they are almost a modern company in a modern environment where they have an open source engine and an open source rule base, which I always kind of felt that it was what's needed to really accelerate the use of static analysis and expand on it. And the company he works for is basically funded, has a nice business model, which is based about providing services around it, which I think is the way to do it, because commercially that's what I would like to engage with. And I think he allows for now a lot of innovation around the engine and the rules. And so everybody enjoy it. And I really want my team to also be actively involved, and we hopefully will be contributors to this. And this is going to be the first of many sessions at the Open Security Summit around Semgrep. So Clint, over to you.
Cool. Thank you so much. Yeah, and thank you for the invitation. I'm really excited to be here. Yeah, so I guess this talk has sort of like a couple of parts. So one is a lot of the workshop is going to be just like hands-on exercises. Hopefully, we'll all be writing some sort of custom security checks together. And then the other part of it is just some sort of ideas how myself and others view the world, because I think it's sort of useful context. So I think it's nice to sort of start off with a sort of an ambitious claim. So I think by the end of this workshop, you're going to, from scratch, learn how to write Semgrep rules. And I believe you're going to learn to do that well enough to find bugs unique to your company. So I think you're going to walk out of this and say, oh, there's this one wonky thing that my code base for my company happens. Like, I want to ban all of those. I think you're going to be competent enough to do that. And if you have any trouble, just hit me up. I'd be happy to help after this. And we're also going to show how to get this coverage continuously in CI. So this is a lot to claim, perhaps for just one session, going from 0 to doing something immediately useful. But I think we can do it. So just to give you some highlights, we're going to write some sort of custom lightweight checks to find either dangerous or functions you want to ban. We'll find injection issues like cross-site scripting. We'll look at extracting like attack surface, for example, all the routes from a web application. We'll find some business logic flaws, so things that are not sort of generic OWASP top 10, but are like really sort of specific to one application. And one thing that I'm particularly excited about is we're also going to show how you can provide an auto-fix suggestion for identified issues. Here's an example of what it might look like. So many security tools can write sort of comments on pull requests on GitHub or other platforms. And here in this workshop, we're going to show how you can use the GitHub like suggestion API to say, hey, this route does not do a JWT auth check. Let's like auto recommend, hey, here's what you should add, so that a developer can just like click it and then apply it. So pretty excited about that. And we're going to be writing rules across a bunch of languages. I believe Golang, Java, Python, JavaScript, and Ruby. So we'll do a little bit of a lot. OK, so here's the workshop in a bit more detail. So first, we're going to talk just some like high-level ideas about like why are secure defaults so powerful, and we'll look at a bunch of very prominent tech players who have embraced them. Then I'll give you a little background about what Semgrep is and sort of like why it's useful. And then all these sections in blue are going to be hands-on exercises. So we're going to be doing some like intro rule writing. Then we'll talk about a methodology for how to tackle bug classes in your organization based on a talk my colleague Isaac and I gave at a global AppSec SF. Then we'll integrate it in CI, and then we'll do some like advanced rule writing if we have time. OK, so one thing that I would love from you all is if you just know, or if you can think of during this workshop, just some code patterns in your organization you'd like to find. I would love to help live write some rules together to find those. So ideally, I would love if the end of this, like the last maybe half hour, was just like totally us. You send me something and then we like try to find it together. So I think that would be more exciting than just some examples I have prepared, because then we can sort of show the process of trying to solve problems together. So let that like noodle in your brain a little bit as we go. Okay, super brief background about me in case you don't know me. So my name's Clint. I am the head of security research at R2C. We're a small San Francisco-based startup. This is our obligatory Zoom pandemic company photo. Before that, I was a research director and technical director at NCC Group, which is a global security consulting firm. So I was doing pen testing as well as helping advise companies on how to scale their application security program, how to embrace DevSecOps, things like that. And before that, I was a indentured servant / grad student at UC Davis. So feel free to reach out on Twitter. I also have a security newsletter called TLDRSec, where I basically read a ton of articles and try to summarize the best ones, the best tools, the best new research, so that you can sort of more easily keep up with what's going on in security. So feel free to check out that as well. Okay, so let's talk about why secure defaults are so powerful. So I think that there's been some significant shifts in tech in the past 5-10 years, maybe 15, right? So we've gone from waterfall development to agile, from separate dev and ops to DevOps, and from on-prem to the cloud. And obviously different companies move at different paces, but I think this is overall sort of a shift we've seen. And I think security is specifically also going through a shift as well, that it's still early on, but I see significant evidence of this a lot of places. Before, there was a big focus on how do we find all of the vulnerabilities. And going forward, I see a number of companies focusing on like, how do we give secure defaults, like secure primitives, some sort of a paved road approach that developers can follow and easily and transparently do the right thing without necessarily needing to always be aware of security. So I have a sort of a thought experiment for you. Let's say I were to give you a random web application that you've never seen before, and I asked you, does this app have cross-site scripting? So probably you'd have a lot of questions, right? You'd probably say, well, okay, so what does the user control? What's the structure of the data that they can pass in from the web application? Does the web app filter the input in some way? How is it stored in a database? Is it stored as like an integer or a float or a string or a Boolean, maybe arbitrary JSON? Maybe the database type matters, MySQL versus Postgres and so forth. The data that's returned from the database, how is it processed? Do we do some sort of like filtering? And then when that data is sent to the user's browser, how is it included? Like, is it just directly put into HTML or an HTML attribute or JavaScript, maybe CSS and so forth? So before you can make an informed guess at how risky this application is with regards to, say, cross-site scripting, there's a lot of questions you probably have. But what if I were to instead tell you, we've enforced this secure default for this application. The front end is entirely React, and we've banned the function dangerously set inner HTML, which is basically a way to opt out of React's default output encoding, such that you're like, hey, I know what I'm doing, like, don't protect me. So because React is such a strong, well-built front-end framework, basically, if we can guarantee that this assumption holds, probably all of these other things are significantly less important. It's a lot less risky. And basically, I think of this as sort of two sides of the same coin, right? So ultimately, we're trying to improve the security posture of our application and reduce our risk to the business. And on one side, it's like, okay, well, can we find all the bugs? And then the other side is like, oh, if we just only use this safe way that we've sort of rigorously vetted by the security team, and we know that it is safe by construction, then we might not actually have to do all of this bug finding in the first place. Another way I like to think about it is, for what task we're trying to perform, like how much effort does that require? So the y-axis is in CHUs, or Clint's hand wavy units. And so in the bottom left, detecting the use or lack of use of like a secure or insecure library, like that doesn't take a lot of analysis complexity, right? Like in many cases, that's just almost grep or a little bit smarter. But if you want to find something that's potentially a bug, that's a little bit more work. If you want to confirm something is a real bug, that's even more work. And if you want to write a proof of concept exploit that demonstrates that that issue is actually exploitable in practice, that's even more work, right? So like each of these things is getting harder and harder, but ultimately, again, it's not about finding bugs. It's about how can we reduce risk. And fundamentally, what I'm getting at is, detecting the use or lack of use of secure defaults is just much easier than finding bugs. It's like, how can we solve like a simpler problem that still gives us the security and safety benefits that we want? Um, in case there's some young people in the audience, I wanted to include a meme so they could relate. Broke is trying to find every vulnerability, and woke is trying to prevent classes of vulnerabilities from happening in the first place. One thing that I think is useful is like, okay, these FANG companies, Facebook, Apple, Microsoft, Amazon, Facebook, like all these people with, super large budgets. They have big security teams with really smart people. They have executive buy-in for security. They are willing as an organization to pursue these long-term strategic initiatives. They thought about this a lot. I think it's illustrative to look at like, okay, what are players like these doing? Because they have, at least compared to my company and a lot of companies I've worked at, they have a lot more resources, right? So what are they doing? Because probably we can take some inspiration from them. So this was a great talk by Scott and Isha of the Netflix AppSec team at AppSec Cali. And here we can see a couple of things they're focusing on, like secure by default, self-service security, and security partnerships. And we can see that this emphasis on secure by default is actually growing over time. Microsoft had an interesting study where they found that 41% of the vulnerabilities reduced from migrating from XP to Vista was basically just banning dangerous functions like stir copy and others. That's a pretty good win for just some greps, in my opinion. This book, Building Secure and Reliable Systems by Google's security and SRE team, is actually freely downloadable online. I encourage you to check it out. But it had some very interesting chapters on secure defaults. And one quote that I like in particular is, it's unreasonable to expect any developer to be an expert in security, like as they're doing their job, and be constantly vigilant when they're writing code. A better approach is to handle security and reliability in common frameworks and languages and libraries. And ideally, these libraries make it so that writing code with these common classes of security vulnerabilities impossible. And I really like this because we expect developers to create business value, to write new code that is performant and scalable on a tight time schedule. And that takes significant expertise that I think many of us as security professionals, or at least I, don't have. So to expect them to also be security experts, which again is like another area that takes probably also years of study, I think is a bit unfair. And so that's why I like that. This blog post by Facebook, where they describe, we invest heavily in building frameworks that help engineers prevent and remove entire classes of bugs when writing code. So in this blog post, they have basically an inverse pyramid where at the top they have secure frameworks, which ideally handles as many bugs as possible. And then they also do, automated testing tools and peer reviews and so forth. So all of these things have a role and they're all valuable, but sort of the base of the pyramid, the thing that they're trying to get the most leverage from is secure frameworks. And here's an anecdote, sort of off the record. This was told to me by a friend at a hypergrowth Bay Area startup who said, we were concerned about RCE and our Node.js apps, so we just banned eval, new function, and other ways to just run arbitrary JavaScript. And basically, they wrote some custom ESLint plugins that ran on every pull request. That basically, if a developer used one of those, it just said, you cannot merge. Please remove this. And then basically they didn't have to worry about these types of issues in their Node.js apps. One thing he said that I thought was a bit funny is you can get amazing security wins if you can be a bit draconian about your coding standards. And of course, there's a big caveat here, right? You need sort of organizational buy-in. You can't do something the engineering team is unwilling to follow. And ultimately, the security team needs to support company goals and not just sort of be naysayers. But that being said, this, I think, mindset and this approach can be quite powerful. Okay, so that's just a little bit on what I've observed many companies doing that they found very effective, and why this is the angle that I personally believe is the future of AppSec, and why this is the angle that we're trying to embrace with Semgrep. Okay, so a background about Semgrep, but soon we're going to hands-on write some rules. So just some background, like why do we need Semgrep? Why don't we just use grep? Because grep is an awesome tool. Okay, so let's say we want to find some particular dangerous function, let's say exec, where if an attacker could provide input, maybe they can execute arbitrary code. So this is scary. So let's look at a couple of ways this could manifest in code. So we could call exec on some sort of string literal. We could call it on a variable. There could be some white space and so forth. So let's say we were trying to find these with grep. So the first thing is like pretty easy. We could just do exec open parentheses. That would work for the second as well. The third example, we have to start matching some white space. That's a little less easy. Then it could be on multiple lines, so we'd have to do some like multi-line regex. Like that's a little bit messier. It's probably going to be hard not to flag this example. It isn't the function we're looking for, but it does look like it. And then these last two examples where we're inside a comment or inside a string, like that's going to be very hard to match with or it's going to be hard to not match that with a regex. So that would be a false positive that's going to clutter up our search. So obligatory xkcd. If you're having Perl problems, I feel bad for you, son. Got 99 problems, so I use regular expressions. So regexes can get you a lot of the way there, but they're difficult to maintain. And as we just saw in the previous example, it's difficult to express complex code patterns with grep. And the reason for that is regexes and grep treat code like a string. It's just like these are characters. But ultimately, code isn't a string, right? It's a tree or a graph. And that's actually how interpreters or compilers view code, right? Because they need to build some understanding in terms of like, okay, this is an annotation, this is a function definition, this is a method call, and so forth. So tree matching or abstract syntax tree matching is not new. There's lots of tools that do it, both just linters as well as security tools. So for example, Bandit, DLint, and so forth. But the problem with all these tools is they all represent abstract syntax trees or code differently internally. So if you in your organization use more than one language, you basically would have to learn how all of these tools represent code. And also there's many different ways to express the same semantically similar thing in languages. So it can be a bit complicated to cover all the edge cases. There are obviously powerful commercial static analysis tools that do these things quite well, but they tend to be a bit complicated to get started. Some of them can be a bit slow, and they're also sort of pricey. Here's an example of an ESLint rule on the right-hand side, where it's like find all calls to eval. And that rule is 307 lines of code, including comments and white space, but still, that's a lot to write for just like, hey, find eval. So ideally, we want to be able to do this more easily, which leads us to Semgrep, which is a open source lightweight static analysis tool. My company, R2C, is building it, but it actually has an interesting history. So we didn't actually create it. It was originally created by Facebook, specifically Yoan Padalu, who is the first program analysis hire at Facebook. And at Facebook, they used it, originally it was called Poof, and they used it to enforce nearly 1,000 secure coding rules internally. So we actually ended up hiring him last year, and we rebranded sgrep to Semgrep and have been building it and adding features ever since. Yoan actually, during his PhD at INRIA, worked on a tool called Coccinelle, which you may or may not be familiar with, which is basically a pretty neat tool that was used to submit a bunch of patches and bug fixes to the Linux kernel. I think hundreds or thousands of bug fixes. So there's actually a long history here. It's not just this new tool, actually. Okay, so a quick summary of like features and like why do we care? So Semgrep is nice for security consultants and researchers in that it's open source. It's on GitHub. It's LGPL, so you can use it quite permissively. It supports many languages out of the box. These and others are constantly being added. There's over 1,000 rules out of the box that you can get started immediately. And also, you do not need to have buildable source code. So if you have, say, partial source code or even just one file, or maybe you can't resolve internal dependencies, you can still use Semgrep, which is actually, if you're not familiar, a pretty big difference from every other static analysis tool that I've used, in which generally they need full buildable source code because they need to resolve functions and classes and types. And there's like a whole mess here that I can get into if you're curious. But I think the biggest thing here, and that's going to be the emphasis of this workshop, is there's no separate painful domain-specific language you need to use. You don't need to spend days or weeks figuring out, like, how do I use this tool? Basically, if you're trying to write a pattern to find Python code, you write Python. If you're trying to find Java code, you write Java. And there's like a couple of helpful abstractions, but really the patterns in Semgrep look like source code. And this is a key differentiator from other tools.
There's a question in chat. Does it support C# and C++?
Yeah, that's a good question. So C#, we actually have a member of the community who is in process of adding support for that language. So I would say not yet, but probably in the next 1 to 2 quarters, we'll have reasonable C# support, and C++, not yet. There's a bunch of reasons why C++ just as a language is hard. So we have gotten a number of asks for it recently. Oh yeah, that would be wonderful. Yeah, I'll send you a bunch of links after this. Feel free to reach out. But yeah, so I'd say C# progress is in progress of being added, but it's still going to be a little bit. And C#, I think we've like tested it, but we haven't really tried to roll it out yet. So still early stages for that. But yeah, we will be overjoyed to help you with adding support. That would be awesome. So yeah, thanks for your question. Okay, so for AppSec engineers and developers, one thing that I think a lot of us have found is, there's these like coding standards or expectations that are either on a wiki somewhere, or maybe just in our brain, or maybe in the code itself. And it would be nice to be able to enforce these continuously in CI, whether that's GitHub, GitLab, Travis, or whatever. And we'll show how that we can do that actually quite easily. Okay, so just to sort of like mentally put Semgrep on like the spectrum of static analysis in your brain. So on one side, the left-hand side, we have very simple things like regexes and grep. On the right-hand side, we have whole program analysis where we're doing control and data flow across hundreds of files. Basically, Semgrep is in the middle where we're trying to get some benefits of both. And I can like go into that in more detail, but that's basically the idea. Sort of a middle ground. So Semgrep at a high level works the same as pretty much every other static analysis tool, which is you go from source code, you parse it into some sort of intermediate representation, such as an abstract syntax tree or a graph. We then take some security checks, and we sort of pattern match those together in the engine, and then out pops security bugs. So I could go into this more detail, but I don't think sort of the details are relevant for now. But at a high level, that's how it works. Okay, so enough talking. Let's get into rule writing, because I think that's more fun. Okay, so basically how I would like this to work is I'm going to do an example, and you can all watch. And then I actually have a Twitter thread where I'm going to tweet like a challenge, and then you can all tweet your solutions back at me. So threading on Twitter is hard, so this may be a disaster, but I am optimistic. We will see how it goes. Okay, so again, Semgrep is open source. It's on GitHub. You can pip install it, or homebrew install it, or run it as like a Linux binary, or run it as Docker. You can do whatever you want. But basically, this live editor is just a nice way to write Semgrep patterns in a nice UI without having to install anything. And also, it's very convenient with sharing what you're working on with other people. So let's look at an example. So this is just basically like a web UI around like forking to Docker in the background. There's no magic here. Okay, so you can choose like a bunch of different languages. This is a sort of simple editor where you can write patterns. Those patterns will be run against this code, and then the right-hand side will show like what are you matching. So let's just say we want to find all calls to exec. So basically, again, it's just like source code. So we're just going to do exec. And then there are maybe 2 or 3 abstractions that are useful for Semgrep. So one is the ellipsis operator, which is basically saying there can be 0 or more arguments. I don't care what they are. So if we do that, let's see what we matched. So we can see here that we matched this string literal. We matched this variable getting passed in. We did not match SumExec because, again, that is not a function named exec. This white space didn't matter. These multi-line call didn't matter. And note that we did not find the comment or exec being called in a string literal. So these would probably be hard to find with grep. These would probably be false positives with grep. But again, we just wrote like a very simple pattern, and it did what we intended. So one thing that I think is especially neat is Semgrep is smarter than just sort of a naive abstract syntax tree matcher. It actually is aware of sort of source code semantics. So here we are importing exec locally, like locally aliasing exec as safe function. And then we're calling safe function on something else here, just like some variable called user input. So note that we are still flagging this because it is actually calling exec, but my pattern is naive to that. Like I didn't have to say, oh, well, I guess, maybe something could be aliased or this other fancy thing could happen. Sort of our goal for Semgrep is how can we make it as abstracted to the user where they basically just say, this is my intention, this is what I want to match. And then we do the smart thing and handle the complex cases behind the scenes so you don't have to worry about it in your patterns, ideally. Okay, so let's go into this a little bit more detail. So if we wanted to say, so basically like the ellipsis operator is kind of like dot star in regexes where it's like just match whatever, I don't care. Sometimes you want to actually match and grab a reference to something, sort of like a capture group in a regular expression where you don't know what the value is, but you want to reference it later. So that we have, again, another abstraction for Semgrep patterns called meta variables, which are basically like a $sign and then some alphanumeric label. So when I say $X, we're saying this is a meta variable. So find calls to exec with just one argument. And yeah, so here we're still matching the same things. But if we were to say, add an additional argument here, now we are no longer matching this case because our pattern, this meta variable is saying we assume that there's only one argument to exec. And because this one has 2, it's no longer matching. So if we wanted to say only match calls to exec with exactly 2 arguments, we could say, pass in 2 argument or 2 meta variables. So that would match these 2 things respectively. We could also say, so we can actually combine meta variables and the ellipsis operator. So again, the ellipsis operator is like 0 or more things. So if we did X and then ... that's actually going to match 3. So now we're saying match calls to exec with at least 1 argument, which will be bound to X, but there could be more. Yeah, so that is sort of the basics. Let's see. I guess now's a good time. So this simple editor is just sort of like a nice UI, but at its core, Semgrep rules are actually YAML files. So if you click to the Advanced tab, you can sort of see what's going on underneath the hood. So here, this is the structure of basically this compiles down to this. So ID is basically the name of whatever you're finding. So we could change this to say like find exec. The pattern is like, this is what I'm looking for. Here's some message. This looks like leftover from something else. So we could say find calls to exec. Yeah, and I'll show you a cool thing in a second. And severity is like warning, info, etc. So one thing that's nice about meta variables is you can actually use them in your message. So if we run this, we can see that this X is matching here to user input, here to ls, here to some var, etc. So basically, like, this is useful for if you are like trying to give developers very direct feedback and helpful contextual. Like, you don't want to just say, hey, this is bad. Ideally, you would like to say, oh, in function foo, you're doing this and you're passing it argument bar, and that's why this is bad. So you can basically anything you match in a pattern, you can include in your message. And we're actually going to see how powerful that is with like auto suggesting fixes for code towards the end of this. Okay, so one last thing, and then you've learned like 90% of what there is to know about Semgrep. So I know it sounds like you've just started, but basically the primitives that I've told you so far, the ellipsis operator, meta variables, that's going to get you most of the way there. And there's just like a couple of other useful things. So one is, sometimes you want to find like not just one pattern. Ideally, you would like to say, find all cases where this is true and this is true, or this or that, or this but not that, sort of like a Boolean composition of patterns. And Semgrep allows you to do that. So if you sort of click this plus, there's a series of other things you can do where you can say, okay, like the code could be this, or it needs to be inside this, like inside this class or function, or you could say, and is not this, and so forth. So let's look at how we can do some interesting like pattern combination. So here we could say, let's find any code, any call to exec, 0 or more arguments, we don't care. And let's filter out the cases where exec is being called. And so this is also a special syntax. If you do ... within quotes, this means like any hard-coded string. I don't care what it is. Like the value could be anything, but just match it anyway. So like let's find all calls to exec, but filter out the cases where the first argument is a string literal. So the intuition here is like if this is just a hard-coded string, an attacker can't influence it, so it's probably not dangerous. So by adding this additional clause, we're making our query higher signal and less noisy. So if we do this, we can see that we are filtering out this case. So this is a string literal, so we're like, that's safe actually. And then we're still finding the other cases that potentially could be vulnerable. Okay, so yeah, basically ellipsis operator, 0 or more things, meta variables like catch a reference to something. You can combine clauses, and there's like some other stuff, but really that's most of it. Yeah. So any questions?
Yeah, can I ask a couple of questions? Can you just show me that advanced thing again? So I just quickly missed that one. Where you add so you put the variables in there, right? Very cool. So one of the areas where I feel that this is really powerful is to replicate what we know. See, the biggest thing I found is that in security, we tend to sometimes go for the unicorn stuff, and we tend to go for like really complex stuff. And more and more, I'm like back to basics. I'm like, look, here's a vulnerability, right? I found this. Automate the discovery of that. Like, it's almost like, hey, somebody submitted a bug bounty. Show me everything that person did, right? And if you cannot see that, then we have a problem, right? Or like we review source code and we found a problem, or somebody, it's almost like there's a natural discovery of vulnerabilities, right? I would say in an environment, right? Either, people paying attention, or by accident, or by being exploited, or even by, as we get more security champions in board. Like, I think there's a natural stream of discovering of vulnerabilities, where I think that's a very sweet spot, is allowing to ask a very simple question, which is write a rule to find that, right? Put it on the CI/CD pipeline, put the fix in, and show me that rule changing, right? Being kind of, basically stop being there, right? And I feel that then the only question is, how complex is the rule, right? But I always take the view that if a human can find it, we should be able to write a rule for it, right? Like, whatever the human is doing, you should be able to codify it. right? And that's why I think this is very interesting. And I think it's very interesting to then find, you know, those patterns and to have those kind of ways to, you know, to automate that discovery, which is really, really cool. And yeah, so I'm looking forward to seeing more of that. One more question I had is, so you don't do intra-file, you know, kind of AST, right? So is your AST limited to one file, or do you glue multiple files together?
Yeah, so that's a good question. So one, let's see, one of the reasons why I included this slide is, so there are some like fundamental trade-offs when you're doing static analysis in terms of like speed versus analysis complexity and precision versus you know, ease of rule writing. So we've sort of taken the opinionated stance that we're focusing more on like speed and ease of rule writing over sort of like fully being able to express any possible code flow. So I actually interned at Fortify when I was a grad student, and I built static analysis tools in grad school with my colleagues. And when you're doing interprocedural data flow analysis, there are clever things you can do, but fundamentally, because of like halting problem things, there's just always going to be imprecisions. And in my experience doing security consulting and like helping tune commercial SaaS tools for customers, oftentimes the longer the call chain was, the more likely it was to be a false positive. So sort of like the intuition behind focusing on local analysis is we know that by constraining the problem, we can be higher signal and less false positives. And also we can be a lot faster. If we wanted to do interprocedural data flow analysis, we would have to be slower, and we probably would need a buildable environment. So because we sort of by design want to not do those things. So like the Yoan, the sort of the lead author of this tool, like he's built interprocedural data flow analyses before, and we probably will add multi-file stuff like eventually, but sort of right now it's not a focus. Not necessarily because it's difficult or, well, it is hard, but it's not impossible from a technical point of view. There's no fundamental limitation why we can't. It's just like sort of not vision aligned with where we're heading currently. And I think conceptually, another way I think about it is like, if like, think of like how people do code reviews, like when someone, when a developer creates a new pull request and like someone is doing a code audit out of that, usually you're looking at the diff and you're probably not reasoning mentally about how, you know, oh, this 2-line change in this file, because of this existing code, like 20 files away, it's actually vulnerable now. I think that if reasoning about many files to understand the security properties of new changes, like if you need to do that, I would say that's actually kind of like an anti-pattern, and that ideally you code sort of tooling and libraries and infrastructure such that you can reason about security properties locally. It's not necessarily easy, but I think that's sort of a powerful way to go.
But you basically will only look inside one function, right? So even if the same function is in the same file, you won't follow the taint data from one function to the other function.
So each pattern runs on like one file at a time. So you can reason about like, oh, this is in global scope and then this happens in a function. Like you can't do stuff like that. But yes, doing sort of like complex taint analysis is it's on the roadmap, but it's sort of not currently a focus.
Yeah, but I'm saying, but if you have if the same file has, for example, a call being made, right? Like for example, that thing you showed, which was really cool, which was the fact that you can pick up the fact that there's a layers, right? So for the like that one, right, as a saved function, right? If there was the data being passed into another function, and then would they use it? Would you like do you follow that? The AST, does your AST stays within the same function, or does it actually resolves that this is actually going to be calling another method inside the same file?
Yes, I'd have to look at a concrete example. I think I know what you're saying, but yeah, the answer is yes. We can either do that now, or it's something that we could add soon. It's not since in the same file, we could do that without too much difficulty.
So for the C# guys on the call, one of the things that I did with the two platform was this insane thing called, I call it method streams. What I did was I used refactoring to basically take a method, find all the calls made on that method and recursively, and then I would basically create a new file that had all the methods from the original one. It was great for code review, but I think for this would be quite cool, actually. So yeah, so we should dig some of that stuff. All right, man. No more questions for me. I think there's other questions that somebody asked you, so go for them.
Oh yeah, thanks for the great questions. Okay, so Arthur asked, can you have a rule that combines both? Yeah, totally. Let's do that. And then, yeah, if we did something like, yeah, so meta variables and sort of quotes, ... Yeah, you can I'm basically teaching you the primitives, like what are the pattern building blocks, and you can arbitrarily combine them in one or more patterns. So yeah, so here we are finding like, okay, the first argument can be anything, and the second argument is specifically a string literal. So that would match this, but not this. So let's see, Kevin asks, since Semgrep is using an AST-based approach, does that mean that you can't explicitly search for things that might show up in comments and are only limited to searching code? Yeah, that's a great question, Kevin. So yes, our parser currently, I believe, throws away comments a bit. Like we didn't sort of intend for people to be able to pattern match on comments. This is a design decision. It's not a fundamental limitation. Like we could change it so that you could do that. It just hasn't really been a need. So the answer is currently no, but there's no technical reason why this is the case. We could do that if you want to. Oh yeah, and Isaac, one of my colleagues, says you can use grep inside Semgrep. Yeah, so one thing is, we're very practical. And one of the features I pushed for early on when I joined was like, hey, like, I want to be able to combine pattern or regexes with like Semgrep patterns. So we'll look at some examples of doing that later, but you can actually have a Semgrep rule that's like just a regex, or you could say, match this, but only if the string that's matched matches this regex or something like that.
Yeah, one reason, Clint, that I asked is because you'd mentioned that you interned at Fortify, and I think one of the worst rules that Fortify has is basically the stuff like password management, looking for hard-coded passwords, both in code and comments. And I think that Semgrep could probably be useful in both of those cases, although in the case of comments, if you're by default throwing those away, obviously that's a little harder. But I mean, you would think that it's like, okay, like look for an L value that's assigned from a string literal or something else. If you don't do flow analysis, then that's probably the best you're going to do. But, they end up like finding stuff that's also R values as well. And it's kind of pointless to do that because it's not an assignment. So, I just, there's, 99.9% of those are false positives. But yeah, when you're reviewing code and everybody's got, some kind of change password functionality or something like that built into it, you get tons of false positives. So that's why I just mentioned that.
Yeah, that's a good point. Yeah, so we, because it tends to be a bit noisy, I don't think we've written a ton of rules like this, but I think it could be nice for detecting hard-coded secrets. Like you said, like you could say something like let's try to find like all assignments to a string literal. And there's actually a couple of things you could do with this. So with pattern regex, you could actually we have a special syntax thing called meta variable regex, where you could say, okay, like, did the thing I match, like, what does it look like? So you could actually do something like,
yeah, exactly.
And I don't think it's actually exposed through the simple UI, but there's like a different key. Actually, yeah. So I was gonna show this later, but yeah. So the simple editor is we're trying to be like, okay, what's the 80% use case? We don't want to like the kitchen sink at you. So you can do like 4 things basically, but if you go to the docs, there's actually like a bunch of other things you can do. And so one of them here basically you can say like, oh, some module and match the method, and then we're basically going to apply this regex against what we matched here. So we could say like, the sort of analogous example here is we could say sort of like meta variable regex, and then like if I don't know, like if the thing that if the variable identifier that's getting matched looks like this, then flag, so it's not like any string literal assignment.
Right.
So yeah, so we can talk more later.
I definitely think that you can do better than what Fortify does. I mean, they just like seem to have not put too much thought into that and just punted. I mean, it's like it's really no more useful than a dumb grep to me.
Well, I actually talked to their rules management people a long time about it, and it's by design. So their philosophy has been, and this may be different under Micro Focus now than when they were HBE and before, but their intent was to avoid false negatives.
Right.
And so they would rather cast a bigger net and generate more noise than to miss it. And so their assumption is that would be maybe input to a manual code review, but in reality, it just makes it almost unusable in a lot of cases, or people lose trust in it. So.
Yeah.
So they wouldn't change. I said, you guys should really change this. And because I pointed out a case where they should be able to, because I've written custom rules in Fortify, which is also not very easy. Using their hidden documentation that you have to ask for them to get. But, and I was like, I can see, I wrote a rule that can exclude the cases that you're flagging. You can know are not actually right, like these kind of things. You could exclude that. Why wouldn't you do that? And well, we prefer to generate them just in case. And I'm like, okay, I'm not going to win that argument if that's your philosophy. But
that's a philosophy a lot of just the security community in general, right? So
yeah,
unfortunately, when you're moving to sort of an agile world, that just doesn't really work anymore.
Yeah, I mean, Jason makes a great point, which is, and it's sort of like one of the reasons why I was highlighting sort of like our worldview and like Semgrep's view. So we've sort of made the purposeful design decision to, based on what we've observed from a bunch of AppSec teams, is that sort of like how you get, if your SIEM is giving you like 10,000 alerts a day, well, that's not really as useful as like giving you that are high signal, even if like you miss some. So similarly, we are trying to sort of specifically like how do we tell people things that we're pretty confident about, even if it's like in some cases we acknowledge that we're going to miss some things. And in practice, I think most AppSec teams I've chatted with agree with that trade-off, and they're fine with it. And you can always ratchet the bar up over time. But yeah, I think so. When I interned at Fortify, it was actually before the acquisition. The acquisition actually happened during my internship, which was interesting because like, oh, should I stay? Should I go? But yeah, like the people who were working there, like super smart, super motivated, very talented. I think just the focus of the engine writers and the rule writers is again like how do we find everything? How do we get like complete coverage? Versus like how do we sort of very focus on sort of like a narrow niche of high signal things. But yeah, the people who were there were great, and I'm still friends with many of them today. But yes, the sort of philosophy behind these two tools is different, and sort of where we view the future of security is, I think, is a bit different. But the people I met there are awesome. But yeah, good point, Jason.
Thanks for the comment.
Actually, Clint, the question: the engine that builds the AST, what is that built on?
Yeah, that's a good question. Okay, so I'm going to try not to rabbit hole too much. So basically, one of the hardest problems in static analysis is parsing source code into an intermediate representation. So basically, there's like a huge heavy lift before you can parse each different language. And then ideally, you then sort of like convert that into like a generic AST, which then your engine can operate on. Like every SAS tool works this way. But like different versions of languages are hard. And like there's like, like different languages are finicky and the grammar is very complex. So basically, for most tools, for most static analysis tools, adding a new language is like 9 to 12 engineering months of work. It's like a huge lift. We've actually taken a pretty clever approach, I think, and this wasn't my idea. It was my colleague Yoan's idea. So there's this sort of parsing project from GitHub called TreeSitter. And basically TreeSitter has, I think, like 30 grammars for like 30 languages. And basically it's like they have these grammar files, and then you can like auto-generate like a C stub that can parse that language. And then we actually take that and embed it in the fancy program analysis OCaml core and use that to more easily support more languages. So basically, if there's a TreeSitter grammar for a language, it's not free. We still have to do some tweaking and customizations. And sometimes the grammars aren't perfect. We actually push back our fixes to their grammars. Like for TypeScript, we improved it a lot. But basically, we tried to not have to manually write and port all of our grammars, which if you're doing that as a static analysis tool company, it's like a massive amount of work. So we try to leverage open source and give back to open source as well. Yeah, so that's like a little bit of some of the internals for how we parse in different languages. And TreeSitter is actually used for code highlighting and jump to definition and stuff like on github.com. They're actually using TreeSitter and supporting projects.
Cool. Is there any parsers for like Kubernetes and sort of CI kind of primitives like Terraform and that kind of Helm charts and Docker files and all that jazz?
Yeah, so there are grammars for a lot of those things, but actually Mark, one of our program analysis team, super smart, and he actually built a, let's see, he actually built a generic mode. So it's still an alpha, but basically we were like, what if we could run Semgrep on any text file and we don't care what the language is? Like, wouldn't that be cool? And so basically, if you use the heuristic that certain tokens tend to mean certain things, like quotes tend to mean like a string, open paren or open brace or close brace like tends to denote scope, and sometimes whitespace does. Like you can actually build Semgrep on any text without even having a grammar for that file. So you don't have some of the power that you do if you have like a dedicated like a grammar support, but you can actually run Semgrep using this generic mode on any text file. So this includes like HCL, Terraform, HTML, Docker files, basically anything that's text, you can at least kind of sort of do it. It's not perfect. Like it can't do, you know, like fancy things like we can in like the programming languages we support, but you can actually do some things. So we've had some people who've written like infrastructure as code rules and like Nginx config lints and all sorts of stuff.
For HTML, if I say I want every single link in a particular HTML or even raw text, then you would just use that generic one, right?
Yeah. Let me. Okay, you're stealing my thunder later, but I'll show you something.
Oh, I'm sorry.
Let's see. Let's see if this works. Cool. So someone on Twitter was like, "Hey, Semgrep is cool. Can I find script tags in HTML that don't have SRI?" And I was like, "Cool. Let's try to do that." And so basically, so this is generic mode. So again, this is on HTML, but it actually doesn't matter. Like Semgrep is not aware of HTML. This is just like generic mode. So you do have some like support for ellipses and meta variables, but it's, you know, it's still in progress. It's still alpha. But basically what we're doing here is like find every script tag. And again, like we don't sort of care what's there and we don't care what's inside. And then, so pattern not, filter out the cases that have this integrity attribute. So basically, you know, it's not going to flag this, but it does flag this.
And in that text mode, does it skip comments? Because I know that's a problem with some of these, is that it'll find examples and stuff in comments and flag those.
That's a good question. Yeah, let's just try. Well, first of all, let's see. So this white space, it's fine. Like, oh, like if the script tag was in a comment?
Yeah, comment that code out.
Yeah. So sure that it's still going to find this, because again, we are not aware of HTML, so we don't have any semantic knowledge of like what it means for there to be a comment in HTML.
I guess you'd need a general and is not in a comment thing for all the rules if you want to avoid that.
Yeah,
Do it?
yeah, we could probably hack around with like a and is not inside this, but the thing about that is like, yeah, it might work. And is not inside. To be honest, I'm like not convinced this is going to work, but we can try.
Yeah, but the way to do that is to add HTML and with JavaScript.
Oh, actually,
as a parser, right? And to add as a supported, so you have an AST that is now understands HTML and JavaScript, right?
Yeah. So apparently this did work. I didn't expect it to work, but yeah. So I didn't expect it to work because Dinis is right. We should have like an HTML parser which like understands the semantics of like what tags mean. That's how you would do like an actual good job with this. But at least in some cases it works without it. So yeah, that was a good question.
Yeah, because this will probably run into edge cases of where you've got these character sequences inside a string somewhere, and then you get into all kinds of fun trying to match the start and end. And
yeah, totally. Yeah. So generic mode gives us like nice coverage of a lot of things at sort of an alpha level, but yeah, to do like a great job in being context aware of everything, we would probably need separate parsers. So Ash asked, can you match Java annotations? So could you match when methods are declared in controllers without an annotation? Well, Ash, I went back in time and answered your question. So this is actually a built-in example on the Semgrep editor. So yeah, so Semgrep is actually great for matching routes because oftentimes, at least in Flask and Java and some other language, they have like these nice annotations. So here's some examples. So this is just like an example hypothetical sort of Spring application where let's say we have this request mapping which says what HTTP method it is. Let's say that because of this application, how it works, it has an auth annotation which is at authorize, and then it passes in whatever sort of permission is required, and then you define whatever it is here. And here's like some other examples. So basically, if we run this, we can see, again, like I've changed the message to basically report back all the meta variables that were matched. And let's see, I'll run it again so it's not grayed out. We can see on this right-hand side that a bunch of like interesting things in the annotations we've been able to successfully extract. So we've actually used this doing some professional services work in terms of like, let's audit all of the routes. So here we see that we're pulling out the method name. If there's a path defined, is this a get versus a post? What are the permissions? Yeah, so basically, we have already written code for like sort of our internal project work where it's like, okay, we do a little bit of code audit where like this code base, this is how they define auth checks, and then let's find all routes without this authorization annotation. And actually later in the workshop, the example that we'll do together is finding unauth Flask routes and then adding a autofix suggestion such that it'll auto comment on pull requests to say, hey, looks like you're not doing a JWT check. Please add this in. So yeah, we'll do that in a bit. But yeah, does this answer your question?
Yeah, thank you.
Cool. Yeah, thank you.
I might have missed this nuance, but are those, the way that those rules are written, are they order dependent on the, like if authorized was before request mapping as an attribute, would it break?
Yeah, that's a good question. So I believe annotation order does not matter. So like, I think our pattern could have these in either order and this code could have them in either order. but there is actually some nuance in pattern writing where I believe like if you have a series of like or clauses, so like if any of these match, I believe that it does match the first one. So like, for example, here it's like if it's this or this or this, if this first one matches, I don't think it's going to run the second or third one because it's like it's already matched. So you don't need to see that it matched multiple times. So what that means is you generally want to write, or one heuristic I use is like, let's write a more restrictive one first, and then like more general below, because then, for example, if you want to extract as much sort of meta variables as possible out, then you have the chance of like matching the most first, and then gradually you get more general, where if the general one is first, you may not ever run the more specific ones. But annotations are matched order agnostic in my experience. But yeah, excellent questions. Cool. So I have an example that I would like you all to try. Also, if you, let's see, I'll paste a link to the slides because these might be, there's going to be a couple of challenges listed in here. And it'll be probably easier for you to just go click on the link, and then you can sort of write in semgrep.live yourself. Okay, so on slide 37, this was the example we just did together. And I included a couple of slides here in the middle just for sort of easy reference. So I'm not going to talk about them, but they're just sort of like an overview of like meta variables and the ellipsis operator and stuff like that. Okay, but if we get to slide 45, this is where the examples start. So let's see. So I'm actually going to, so I thought something that would be fun is like, can we basically like solve these together? So I'm going to tweet another prompt, and then, but this is what it's going to be, this Ruby exec example. And then feel free to try to solve it and then respond to me if you want to. You also don't have to. You know, if you think that that's stressful, like, don't worry about it. Yeah, so in Ruby, exec runs the first argument as a shell command. This could lead to arbitrary code execution if, you know, user input is the first argument. And let's, so this is basically like an adapted version of what we looked at for Python, but for Ruby, just to show that, you know, we can do this in any language. Okay, so let's see, there's a little bit of nuance here because yeah, I tried to make it like a little more complicated so that you could play around with meta variables as well as the ellipsis operator and combining clauses. So one thing that's interesting about Ruby is that if there's just one argument, it'll do like shell expansion, but if there's more than one argument, it won't. So the goal here is let's write a Semgrep rule such that there's only one argument and that first argument is not a string literal. And just some like tips. So in this test code thing, I've sort of annotated what I expect to match and what I expect not to match. So if you see like rule ID and then some string, this says I expect Semgrep to match this. And this rule ID, if you go to the advanced tab, is just the same thing. So whatever is here, the syntax is like rule ID : and then whatever this ID tag is. And then if you do like a comment and then just OK, you can also do OK : and I think the rule name to be more specific. But basically that's like, OK, I expect not to match that. OK, so I've included a bunch of test cases. And yeah, see if you can match this one, but not any of the others. I think all of the other ones were to not match. Yeah. OK, so I will give you a few minutes to work on that. Again, the specific example is here. The tweet itself is here. And
did you just paste that into the chat window too? So the link.
Yeah, I believe I did. Do you?
Oh, okay. I didn't check it.
Oh, I just posted it like 2 seconds ago. Yeah, and as you're working on these, think like, okay, like what's something in my organization that I really want to find? Because ideally, the last bit of this workshop will be like just, you send to me. Oh, also, I think, sorry, I forgot to reference this. So if you, like, as you find the solution, you can say, like Ruby exec solution or whatever, and then save it. And then now this has given it sort of like a permanent URL here. So you can then include that in your tweet, or send it in the Zoom group chat, or do whatever you want. So this actually has been really nice because like when we're troubleshooting issues internally, or other people have questions and they're like, hey, I want to find this code, being able to easily share a link is great. Okay, so Andre asked, performance-wise for huge files, how does it perform compared to grep? So grep and regrep are obviously going to be significantly faster because we are doing a ton of work that they're not doing. We found in practice that we, depending on what your patterns are, there's so there are some more general things that you can do, like if you use, say, like a lot of ellipses operators, or if you use some other more advanced operators that do like deep expression matching to sort of do fancier things, that can slow it down a little bit. But I would say in practice, we often get like 10,000 lines of code a second or so. So we can scan like a full, like a bunch of rules on like a massive code base in yeah, so it's fast enough to run like in IDE on file save and not feel horribly slow. If you include it in GitHub as a linting tool, we only scan like the files that are changed, and usually a lot of the time to run is actually based on the GitHub Docker image booting up, not our scan. Our scan is actually faster than booting up the GitHub Action Docker image. Yeah, so I would say, yeah, on like one huge file, it depends on the pattern. It depends on how long the file is, but I would say, yeah, probably less than a second if it's just one pattern. If you're running like minified JavaScript, for example, if you're bundling in like thousands of lines of code into one file and you're running rules that are like very permissive, then it could be like a few seconds. Yeah, so yeah, actually, okay, let me like bring something up for a second. Yeah, I have like some random repos that let's see. I forgot where I put it. No, there's oh yeah, my second monitor is above this one. Okay, let's say GitHub Ghost, yeah. Yeah, so this is just like to give you an idea of speed. Okay, so let's just like clone this guy down into temp. Maybe I probably should have done shallow clone. But anyway, basically, I'm just going to run like the default Semgrep rule set on this random repo that's like a real professional code base, just to see like how long it takes. Okay, let's Okay, nice. We've got some answers pouring in. Feel free to also include like a link to the Semgrep .live answer if you wish. Yeah, I wish threading was better on Twitter, but hey, Spiros. Okay. Thank you. Okay, so here we have Ghost. I just ran Toke to figure out like how much stuff is in it. We've got about like 200K lines of JavaScript and a smattering of other things. Let's say, so we've been focusing on like rule writing so far, but oftentimes you're just like, okay, what do I get like out of the box? So we have again over about 1,000 rules that we've grouped into various rule sets. So this one is like if you just want like high signal security checks that you want to put in CI, this is pretty good. If you want sort of a more noisy auditing thing that potentially finds more issues, you can use this. So let's just do like the CI rule set for now. Let's just copy this. Then, yeah, so we're running 119 rules on about 200. Oh no, sorry, this was blank lines. No, this is actually about like 140K or 110 non-comment lines of JavaScript. So, okay, so again, the CI rule set is aimed at being like not noisy at all. But yeah, so we just ran about 120 rules on maybe like 140,000 lines of JavaScript in like I don't know, like 20 seconds or something. So again, this is it's not magic. There are just fundamental challenges in doing like this fancy interprocedural data flow analysis. And because we focused on being fast, lightweight, and easy to customize, we're able to do things like this. So we haven't solved unsolvable problems. We've just made certain design decisions that I think make sense given how software is developed now. Okay, so how do I? Now you can see how I don't know how to use Twitter, really. I should have thought of that beforehand. Okay. So yeah, no, thank you for the great question, Andre. Cool. So yeah, so let's go back and see what to do. So yeah, if we do this and is not this. Yeah, so Sean, this is pretty good. We have matched this one, which we did intend to, and we did not match this one, which is great. I included these examples as sort of some Easter eggs for you. So notice that here we are saying, this is not a string literal, but notice how here, like, this isn't passed in directly, right? It's like variable equals string, and then that string is used, and here it's like a constant. So this is another benefit of using like a abstract syntax tree approach. Well, actually, it's more of like a Semgrep than if you were to do like a straight abstract syntax tree comparison, then it would be like, oh, this is actually a variable. But Semgrep does some constant propagation for you to say, oh, this is, I can prove that this is actually a string. So I'm going to, listen to what you meant there. Oh yeah, good point, Kevin. So yeah, meta variables need to be uppercase. So like $X. So if you do like lowercase, that will not work. That's sort of a design decision we made just to try to make it more clear how to disambiguate a Semgrep pattern from the source code itself. Yeah, so this rule is close, but it's not quite right because we're still flagging these, right? So how do we want to like not flag these cases? Let's just say that if there's more than one argument, it's safe because we don't do shell expansion. That's sort of a generalization, but just for the exercise of writing another rule, let's do that. So yeah, any thoughts? Okay, so let's say like, well, we're saying it's safe if there's more than one argument. So how would we say, okay, Jeremy, nice, yeah. Yep, also filtering out the string literals, that's great. Okay, let's add one more clause because we want to say that 2 or more arguments is actually okay. So how would we do that? So again, we can't do ... because that could be 0 or more. But we can do is say, like, let's say x and y. So this would match exactly 2 arguments, but really 2 or more is fine. So let's put a ... after that. So we're saying, OK, find all calls to exec. I don't care about the arguments, but filter out the calls to exec such that there's only one argument, and that argument is a string literal. And also filter out the cases where there's at least 2 and then plus 0 or more arguments. So Jeremy asks, with only the single x in the first, it matches only call. Yep, that is correct. Yep. So if you had, oh, no. Oh, sorry, you're right. Yeah. I misinterpreted you. You are correct, Jeremy. Yeah, so I was thinking when I created this exercise, let's combine these two and make it a little bit fancier, but you have solved it a better way. And actually, my apologies, Sean, you did as well. I didn't mean to misrepresent you. Yeah, so instead of doing ... here, if you just do $x, that will match just this first one and not the later ones. So this is, I think, an illustrative example where there's actually many ways, oftentimes, to write the same Semgrep rule. And it's a little bit art and not just purely science, because there's like different ways to think about it. You could say like, oh, let's, yeah, nice work, both of you. You beat me. Because you could say, let's find something really broad and then sort of narrow down, or like do like a series of pattern eithers. Like there's a lot of ways to approach it. And honestly, I would just take sort of a data-driven approach where like how often I write rules is like, okay, let me write like a very naive, dumb version. And then I just keep improving it based on sort of test cases until it does what I want it to do. Cool. Awesome. So let's look at this next example. I'll paste it in here. And yeah, so in Golang, when you are creating a TLS config option, there's a couple of insecure settings you can pass in. So you could say, we support SSL v3, which is an old cipher that we don't want to use. You could say, don't verify the server certificate, which is also not good, because then a man in the middle or a person in the middle could intercept our traffic. And then here's like an example at the bottom where both of those are not using bad settings. So here we want to find these first 2 structs, but not the last one. Yeah. So I will also add this example as well. Okay, cool. I'm going to step away for one moment to use the restroom, but yeah, feel free to tweet out responses or just post them in chat. And yeah, I'll be back in one moment. If I can Yeah, also feel free to take like a 5-minute bio break, if you will, because yeah, got lots more coming. Hey there. Yeah, let's see. Yeah, how's everyone doing? Do people like this sort of like live exercise workflow, or what would you think is more useful? Like perhaps just, would you like me writing it, or do you like taking a stab? What do you think?
I like having it live. Makes you think.
Nice. Yeah, I thought that might be a little bit more fun than just having someone tell you the answer. Okay, I'll give it another minute or two, and then we can move on. Okay. So, all right, let's see. Does anyone? Don't know if anybody responded, but yeah. So let's see what we can do here. So, what is sort of the bad stuff we want to find? Well, it's this TLS config. So we can just sort of copy this code in directly. This is sort of a nice place to start sometimes. I'll be like, okay, this is the code that I'm looking for, and then I sort of gradually abstract it away. Okay, but there's a lot of this that we don't care about. So we probably don't care about this keylogger writer. So maybe we just, say like whatever can happen here. This min version is, something that we care about. So that's probably bad. Let's see, this other stuff is okay. So let's just add an ellipsis operator there. Oh man, this is not clear. There we go. Yeah, so basically we're saying this is creating a TLS config object that is setting this min version to SSLv3, which is bad. And there could be some stuff before or after. We don't care. So the ellipsis operator is 0 or more arguments, but it can also apply to statements or to like attributes in a struct. So this other example that we wanted to find is where this insecure skip verify is set to true. So it's actually pretty simple. We can just add another or is clause and say this time insecure skip verify, when that's equal to true, we do not properly vet the certificate of the server. So basically, we're just codifying like this is a bad pattern, this is a bad pattern, and so forth. So conceptually, you could say like for this, whenever our developers create this type of object, these are the settings that either should always be set, or these are the settings that should never be set. And Semgrep is sort of a nice, easy way to do that. So basically, we took one of these cases, right? This is the part of it that's bad. So let's add a case for that. Then this insecure skip verify is another bad thing. So then we just added a series of cases. And then bam, that is all. Any questions about this one? Yeah, probably. I agree. Kevin says that probably should be TLSV 1.1 or greater, maybe even like 1.2 or 1.3. Yep. Yeah, this is just an example. Whatever your policy is, we could probably, probably like a better way is if we were to sort of enumerate what are the sort of versions of TLS we allow, and then, and then just like enumerate those. Right. Thanks, Timo. Thanks for joining. Okay, so Andre says, make it more if it's not checkout ng-lint. TS-lint support is discontinued and we're deprecating its support in Angular. Sorry, Andre, I'm not exactly sure what your question is.
I mean, it was more a note for you to watch later. I think I distracted you there. It is about the discontinuing that we're actually doing on the latest version of Angular. And somebody can actually write, it wouldn't be me, mate, but somebody can actually write a linter based on what you just showed me that can, fill up the gap coming on Google. And you'd have a very large community behind it. Like from what you showed me and the speed that he has, you would be performant enough to actually do that job.
Yeah, that's an interesting point. So the point is TS-lint is being discontinued and we're deprecating its support in Angular CLI. I think basically the idea is there are many linting tools, and for some of those, like could we just have Semgrep be like a meta linter that supports all of these, or in part replaces the functionality of some of these? And the answer is yes. I think that is sort of where we want to go. While we are currently focusing on security, ideally we just want to build a better, easier lint that developers can use. And we have seen some developers at companies be pretty excited about it because like, oh, this is like way easier than writing like a custom tree visitor pattern, which you often have to do in ESLint and other tools. It can't currently do everything that existing linters can do because like some of them operate on like code formatting or like comments or like stylistic things, which Semgrep could do. It's just like not a focus currently. But a lot of the checks that linters have, I think we could replicate in Semgrep. So yeah, that's a good point. So Petra asked, how would we run this on our whole source code, like GitHub Actions? So we're actually going to do that in a little bit. We will see how basically whatever CI system you use, whether that's GitLab runners or GitHub Actions or Travis CI or Circle CI or whatever, because Semgrep is just like a command line tool or a Docker image you can run, and you can pass it a --JSON to have like a JSON output. So it's actually pretty easy to put into whatever CI you use. So we'll actually look at that in a second. Okay, so let's look at another example. Yeah, no problem. Thanks for the question. Okay, so there's another cool thing that you can do with meta variables and ellipsis operator, and you can use it to sort of model how code flows through a function. So for example, this is a Flask example. So here we can say we are defining a route, and then here this file name argument that's passed in is first printed to the screen, but then we are basically sending the file back So the user is providing us a file name, and we're just like arbitrarily sending them something from our file system back. So this is potentially a problem, right? Because if someone says, Etsy password or something, we could be stealing files from the server. So how would we do this? We could say like, all right, let's just copy this code up into the pattern. And we perhaps don't care about what this argument is. So we can just say ... We don't know what the route's name, like what that function name is going to be. So we could just do that. This argument might not be file name. It could be anything. So we're going to change that to a meta variable as well. This print statement doesn't really matter. So let's just delete it. But there could be one or more statements in the route before the send file call happens. This comment doesn't matter. And then again, it's not necessarily file name, it's whatever arg is. And this is sort of a subtle thing, but in Python, we actually do sort of like name resolution. So you actually have to do, I think, flask.sendFile here, not just sendFile, because that's its absolute path. The behavior of this is actually a little bit different based on language, so you might need to play with it a little bit. But do this, we can see that we flag this. So if you think about it, we're basically telling Semgrep sort of conceptually how you would describe the security issue to like a friend of yours. You're like, well, there's like some route, and then the user provides some argument, and then some stuff happens, and then eventually that argument is passed to the send file function. So let's look at these other test cases. Here, send file is like a hard-coded string, so like that's probably safe. Here, it's like, well, okay, we're still like using some variable, and it's not something the user controls, so that's probably safe. But here, there is a base path, but we are actually using the user input a little bit. So the attacker could do some sort of like path traversal where they do ... /... blah, 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 all the way to something bad. So this probably is a case that we care about, that we're currently missing. So I'm going to teach you an additional sort of Semgrep syntax called deep expression matching. And basically, it looks like this, where you do less than sign, ... and then some meta variable, and then ... greater than sign. And basically what this means is here there is some expression. I don't necessarily know what it is, but somewhere in that expression is this meta variable. So here we can see that the variable or the attacker input is sort of appended here at the end. It's not just like the only argument like in this first simple example. So if we run this, we can see that we flag both of these now. So again, this argument is somewhere in this expression. There could be other stuff. It could be maybe like a function call or just other complicated expression, but we're still going to match. So this is nice for like not having to care about like all the different edge cases. But again, I think there was a question earlier about performance. So deep expression matching, because it is sort of like a more complex analysis, if you do a ton of deep expression matching in like one pattern, this could make the rule a little bit slower. Like still, it's going to be fast-ish, but it's not going to be like blazing fast like some other things.
As far as the structure of the rule, right now it's matching only when that's on the return line. How would you generify it? So it could be returned to a variable and assigned and then.
Yeah, so if this was like assigned to some variable, and then yeah, let me create another example that I think is representative of what you are asking about. So something like is this an example maybe? Where it's like they're doing like some other stuff with it?
Oh no, I was just thinking of what if send file was invoked not on the return line, but before that? And the result of that was like to a variable with a rule break, the way it's written.
Yeah, it's a, yeah, that's a good question. Let's just say like that. And then something like this maybe.
Mm-hmm.
Yeah, it probably won't match. Yep. That, so I think in general, like this is like you're returning like a server response. So I think generally you would have like probably a return here, because I think setting it to a variable, I don't know if that makes sense semantically, but I think in general your question is appropriate. But yeah, so we can remove the return to make it a little bit more generic. So that's still going to find this, even though it's not just strictly a return. Does that answer your question?
Yeah, perfect. Thanks.
Cool. Yeah, it's a very good question. Yeah, so it can be a bit finicky catching all the different cases, but we tend to try to take a data-driven approach where we see like, oh, what are the various bugs that have happened historically? What sort of feedback are we getting from like security tools, bug bounty, pen testing, things like that, and then sort of like codify that domain knowledge as well. Yeah, one thing I don't think I've mentioned yet, but we actually have this internal sort of like MapReduce platform where we can take Semgrep rules and then run them at scale across thousands, tens of thousands of repos from GitHub. And we actually use that for writing rules oftentimes. So we're like, okay, I think this is a good idea, but how does it actually perform in the real world? So then we're like, okay, this seems good. And then, we look at like, 5,000 repos and we're like, okay, well, we found these cases, which are great. We missed these cases, so let's make the rule a little bit better. Or, oh, these are false positives because of this. Let's add some cases to filter out that noise. So I think like being perfect is generally not possible, but we do try to model things based on how issues tend to appear in the real world, not just like conceptually how we think they might happen. But yeah, if you come across any false positives in our default rules, we would love pull requests or just feedback and examples on like, oh, you should have caught this, or like you did catch this and you shouldn't have. Okay, cool. So that was.
Yeah, we have developers I've seen are very creative at making the fast rule happy, but not actually fixing problems. So.
Yes, that is definitely true. Yeah, ideally we could just make it very easy for them to do the right thing. So then, and ideally we can stop bothering them with things they don't care about, so that they don't feel like they have to do that. Okay, so we just looked at an example of how to sort of track user flow through a function using metavariables. So I have a challenge for you all to do basically the same thing, but for a Express application, Express.js. And so here we have a get route on a specific path where we are taking name from a query parameter, and then we're just returning it directly. And here we are taking email instead of name. Maybe we're doing something in the middle, and then we are including that in the response, but it's not the only thing. So basically, if you leverage what we just learned, it's a very similar process. So feel free to give that a try. And I will also share this challenge in case. Oh, nice. Yay. Congrats, Henry. That's super exciting. Yeah, do we have a GIF that we want to share with Henry? Maybe applause.
Sure.
Kind of like crowdsourcing this. What do people want?
The first one is good.
Nice. Cool. So let's just add the this one. Okay, so let's. Oh yeah, so the next one is the Express one that I just put in the chat. I'm just sharing the example also via Twitter in case there's people who like come across this later and are not here but might want to give it a try. Okay, cool. Yeah, so my hint for you for this one is if you just want to sort of like copy and paste one of these up into the pattern and just like start abstracting things away, you know, like turning something into the ellipsis operator if it doesn't matter. If you don't know what the variable name or attribute is going to be, just make it a meta variable instead and just use that consistently. And also remember the deep expression matching operator for this last guy is sort of the trick there. So yeah, I'll give you another minute or two, and we'll do the next one. So shout out to Hardword6. This looks like a correct solution to me. So let's quickly see how and why it works. So if we just copy this code in, we can say, well, the path doesn't matter. We don't know what the request and response variable might look like, what the name might be. So let's just replace those. This could be some like variable name. We don't know what it is, but eventually it's going to get passed down to that. And yeah, this is some sort of like query name thing. Some stuff might happen in the middle. So if we do that, we can find this first case, but the second case, because it's not just that user-controlled object, we need to do the deep expression matching. Like this. Let's see, did I? Oh, sorry. This actually should be response. Oh, sorry, I forgot to change this one too. But yep, excellent job. You also get
I like the minions.
the minions? Okay. Yeah, the minion ones are great. Okay, so Jeremy had a question. Unfortunately, this version doesn't seem to work. Let's see what we have here. Ooh, pasting, yikes. Okay, maybe. Maybe I'll just like copy this and then let's see. So, okay, see you, Andre. Thank you very much for coming. Okay, so this and then rec res. Oh, okay, yeah. So basically, it's like, oh, can you just do it all into here? Yeah, so I think the reason this is not working is probably because this isn't like a direct passing it in. because you're assigning it to a variable first, and we're sort of modeling that. If we were to add a case like this, that probably would work, I imagine. Yeah, so conceptually, if you're like, oh, there's a couple of ways this could manifest in code, we could just add a couple of cases. And that is actually like in the official rules, if you look at the Express.js cross-site scripting ones, that is how a lot of them are, because we're expressing like different ways that this malicious code flow could happen. But yeah, that's a good question. Okay, cool. Let's see. So
why is it that in that request.query.name, you are putting a $sign like param or $name? Mine seemed to match without it. What am I missing?
Sorry, here or?
Yeah, if you didn't put param but just put .name, not that specifically.
Oh yeah. Oh, just like this.
Yeah.
Yeah. So basically here, that is going to work because like the query parameter you're pulling out is exactly name, but if you were to say like instead of name it was like email, or like some variable or some like attribute name that's not just name.
Yeah, I see. Okay.
Yes. So the goal of like making this a meta variable as well is we don't care what that value is.
I got it. Got it.
But yeah, that's a good question. Yeah, so basically my process is I sort of look at it and I'm like, okay, what has to be the same and like what could vary, and then anything that could vary I try to sort of abstract away.
Yeah, I misunderstood. I didn't read the code carefully enough to see that it was not a specific case, but that was a generic way that it modeled the query string params. It's been a while since I've done JavaScript UI.
Yeah, I probably should have given it a better variable name so that was more clear. But yeah, good question. Okay, so yeah, so Kevin asks, is anyone building Semgrep rules into IDEs like Eclipse or IntelliJ? Given it's way easier to write rules, it seems like it would be a great addition to SecBugs. Yeah, so in fact, yeah, so there actually is a VS Code extension for it already. And as of yesterday, I learned that a friend of mine has actually written sort of a prototype extension for IntelliJ. So they haven't released it yet, but they probably will sometime in the next, maybe after Christmas. But yeah, so you can, if you use VS Code, you can use this today. If you have a different IDE, we'll probably add that in the next couple of quarters. It is an ask we're getting a lot from people, so it is probably something we're going to focus on next year. So yeah, that's a great question. Okay, so yeah, any other questions? Cool. Well, yeah, feel free to interrupt me anytime.
Oh, one quick thing I noticed in the way that that's written, you know, starting with the original code, you include like var, but if somebody happened to use const or let, that would be a problem. So it looks like if you want to generify it further, you just remove, the var or let and just say any assignment. You don't care what it is.
Yeah, that's a good question. Yeah, I think, yeah, so I think if this is like a let or a const, it might still work. I think Semgrep might be able to reason that that is like functionally equivalent. But let's try.
Yeah, if the rule has var and the code has var or let, it'll work. But if the rule has let and the code has var, it won't match.
Oh,
So
did you?
it might be. So if you want to catch any assignment that you don't care, what scoping that is, then maybe you just, it seems like you just exclude the var and match any assignment.
Yeah, let's try. So you were saying like if we make this like a let or a
Const.
Yeah, let's. So we did actually find both of those.
Yeah, but if you change the rule to a let, it will probably only find one of them.
Yeah. Yep. Yeah, so var, when you're like doing assignments, var seems to match var or let or const, but yeah, let will only match let, and because I think those are like semantically different. I think part of
You just have to be careful, I guess, how you're writing your rule. If it doesn't depend on the scoping of the variable, you probably should just skip it.
Yeah, there is some sort of like art in how we determine like how should Semgrep behave, and I think one of the decisions we made is based on how people were writing rules that normally they were like, well, when I write var something, I sort of expect it to match these other things, but because let and const have more specific meanings, we're like, well, we can't really go like the other way. But yeah, that's a good point. There is some subtleties, so I would encourage, just try as you write a rule, be like, oh, what are the things I expect to match, and like, am I actually matching those? But yeah, great point.
Oh, it's interesting. It looks like if you split the definition, the declaration from the assignment, it doesn't work. Let's see.
Oh, yeah.
Is there a way to match regardless of whether it's a direct var something or assigning to a variable that already exists in scope?
Yeah, so we do have some, thanks for joining. Yeah, so Jeremy pointed out that if we like take out like the var, like this will match all the cases, which is a good point. And then Jason, your point was like, what if there's like a series of assignments or calculations that eventually lead to it? We do have some initial work that does do basically exactly that. It's not quite ready for prime time, to be honest, but it is something we're working on. So as sort of like a short-term fix, you could sort of like have a couple of cases to say like, these are like, the variable getting passed around a few different times, which is not a great answer. I agree with you, but it is something we are building into the engine in the not too distant future.
Okay.
Okay, cool. Let's see. So we've talked a couple of times. I don't know why. It's, basically, let's hypothesize we have like some business logic that we would like to enforce. So we've been talking about like security issues so far. So what if, for example, this hypothetical financial trading application, there's like transaction objects that we need to call like verify on before we pass them to make a transaction. And if like we just directly make a transaction, that's bad. Or if we call them in the wrong order, that's bad. You can imagine us doing some sort of like sanity checking or vetting of if the right attributes have been set and so forth. So I like this example because it's not necessarily just a security check. It's like, oh, what are some like business logic things that we want to enforce that are specific to our application? So let's see, this is looking wonky. Okay, so let's say here we have verify called before make, that's okay. Or if we just call make, that's bad. If we call them in the wrong order, that's bad. But just calling verify, that's okay. And there could be like other statements in the middle. So conceptually, what we can do here is say, find all functions. We don't necessarily care what the return type is. We don't necessarily care what the function name is. Arguments, whatever. Somewhere in there, they call make transaction. Let's see, question from Kevin. Let's see, I know you said that you weren't focusing on control or data flow analysis, but if there was a way in the Semgrep rules to mark something as tainted and then check it later, then that would allow you to add checks for output encoding and so forth. Yep, totally agree. So we do, like when you use meta variables and like you use it here and then there, like we are doing some control and data flow analysis already. Like we're not doing it like across many files, but within one function or within one file, we are doing that to a limited extent. And also that's how we know that, as we saw in previous examples, that something is like a constant string, even if it's not defined right there, like it could be in a previous variable or something like that. And we sort of propagate that knowledge. Yeah, so we do have like some initial support for like intra-file taint analysis. To be honest, this is like sort of like early stages and not sort of a main focus, but that is something that we will probably be fleshing out in the next year or so. So yep. Nilesh asks, is it possible for CVE data to be linked to these code patterns? Yeah, that's a good question. So one nice thing about using this YAML syntax is that you can actually add in like an additional metadata key. Yeah, CVE or CWE. There's this metadata tag in any rule where you can actually put whatever you want in there. So if you go to, let's see, Semgrep rules, let's see, let's search for CWE. Yeah, so this is an example rule. This is just in the Semgrep rules GitHub repo. So you can actually see that there's this metadata tag, and we just have added this like OWASP key for like, which OWASP top 10 issue it's related to, or CWE for which CWE it references. So what's nice about this metadata tag is like whatever you put in there, Semgrep will just arbitrarily or just blindly pass that into the JSON output, or just print it to the screen if that's what you want. So basically, like if you have some organization specific identifiers or like you want to like slice and dice the data, you can put whatever you want in here, and it just works. We are not opinionated about what goes into this sort of blanket metadata key. It's probably some docs on that as well. Yeah, so if you sort of go to the docs page and search for metadata, it's basically like, yeah, put whatever you want in there.
Just a suggestion to you, Clint, if you're going to start writing rules that have OWASP top 10 stuff in it, you might want to put the year in it too, because they change like every couple of years.
Yeah, totally. Yeah, when we started doing that, we were like, oh, this is going to be a pain. Yeah, so one thing we're currently working on is doing like versioned rules where you can say like, yeah, this is like V0 of this rule, or tie it to some specific release or date or something like that. Basically exactly for that version, which is
right. But I mean, it's like CVEs and CWEs are basically stable. They don't change, but the OWASP top 10 does. So
yeah, definitely. And by being able to say like we could have well, yeah, you're right. I agree. Another sort of, I think, related problem we have is like what happens if people are using one version of a rule and then we like change or improve that rule over time? Like how do we sort of like with like a Docker image or whatever, where you have sort of like this release or like latest or whatever, we probably will do something similar in rules.
Right.
That's not there yet, but yeah, that is that is a limitation we are well aware of. But yeah, it's a good point. Thank you. Okay, cool. So yeah, why? Oh yeah, so there are some things that you just that are not supported in the simple editor. So if you like make some changes in the advanced tab and then switch back, it will sometimes be mad at you. But here, I think that that's okay. Okay, so basically what we're going to do is find every function that calls make transaction anywhere inside it, and then filter out the cases where verify is called first. So conceptually, it's like, what are all of the functions that potentially could be bad, and then filter out the cases that we know are safe. So if we look here, this function we're calling make transaction, but we're not verifying it first, so that's bad. If we call them in the wrong order, that's bad. Just calling verify, that's safe, no problem. There could be other statements in the middle. That's what the ellipsis operators are for. And this last example is interesting because we actually are calling verify and make in the right order, but we are passing this other transaction object instead of this one, so other versus t. So this is a false negative. Like probably we care about this case, but we are not accurately catching it currently. But what we can do is change this to $t and $t to say these must refer to the same variable. And then we do appropriately flag this case. So again, the point of this example is like we had this idea in our head of something we want to find, and then we found it in like 9 lines of code or so. So this is something you could roll out in CI.
Is there a way to deal with the ancestral function? So if verify is called in a parent function or a parent function of a function, can it detect that in the ancestry of?
Yeah, it's a good point. Like maybe in real complex code, there's like some like there's this one function that's calling verify inside, and then it calls this other function. Other stuff happens, then it calls a different function, and then like make transaction eventually happens. And you want to know like in this program path, are these property hold? Yeah, so that's a good question. I would say currently that is not directly supported. You could potentially chain some Semgrep calls together to try doing something like that, but that is something that we would like to support in the not too distant future. But currently, I would say that's not trivial to express. Yeah, does that answer your question?
Yeah, thank you.
Yeah, so there are, I think, some excellent use cases and desired features that you all are pointing out that I very much appreciate, and is something I want as well. So yeah, there's a number of things on our roadmap that not quite there yet, unfortunately, but hopefully not too long. Okay, so just doing a time check. I think, so I do have another challenge here that I may just let you all solve asynchronously. I will you have access to the slides, I'll tweet it out. But it's just like another example of a business logic thing that you might want to implement where like, oh, maybe you need to call, if you call some function, you need to call it like twice or more for whatever reason. It's kind of a random example, but it's really just to demonstrate, this could be arbitrary things that you might want to find. Let's see. So we already called out the VS Code extension. So we've been writing rules so far, but let's say you're like, well, I just kind of want stuff out of the box. So again, you could use like a CI rule set or more of like a security auditor rule set. Something I'm going to talk about more in a second is we have some packs for enforcing secure guardrails. Also, just like, again, like development best practices, we have some checks for that, not just security. And one thing that's kind of nice is rather than running a bunch of different security tools, you could, we actually ported a number of the open source security tools checks to Semgrep patterns. So you can take a look at how those look. So you could get, Bandit's Python checks or ESLint checks or Java's FindSec bug checks or, GoSex checks or Node.js scan, which actually uses Semgrep as its rule engine, by the way, which is kind of interesting. If you want to just like search all of the rules itself, you could do that as well via this sort of explore and then rules tab. And you can filter by like language or category or sort of like arbitrary text. So if you were like, show me the like JWT rules, you could see those. If you wanted to, I don't know, filter just to like Golang, you could do those. So yeah, like sort of like whatever you want to do. Let's see, probably React should be all languages. Yeah, so feel free to explore that. And again, this is just like a nice front end for this Semgrep rules repo. And I think we pull in rules from a couple of other Git repos, not just this one, like from the community. But this is just sort of a clean way to search. Let's see. So to be honest, I don't think I'm going to have time to go through this part in detail, but I do want to mention it at least a bit. So
we can make it part 2 and have it in the January section.
Cool. Yeah. Yeah, that would be fun. So I'll maybe just give you like a brief overview, and the slides are already public. They're on Twitter as well, and I think I linked them in the Zoom chat, but I'll link them again at the end. So basically, this is sort of like a condensed version of a global AppSec SF talk that my colleague Isaac and I gave. And it's really just like, okay, assuming you buy into the vision of like secure defaults and guardrails and paved road, like how do you actually do this in an organization? It's sort of like more like we've been very tactical with like Semgrep rule writing so far, but this is more like philosophically at an organization level, how do you roll this out? And the answer is like, it's hard, it's not easy, but this is an approach that I've seen a number of companies use to reasonable success. It's again, like probably a multi-month or multi-quarter effort, not like you just do this in a day. But this is sort of like a high level approach. And I'm not going to go through it in detail because I think it makes sense to maybe do some hands-on stuff together, but I would be happy to chat more about this later. So basically, the first step is like, which vulnerability class do we care about? Then like, how do we actually find that at scale or prevent it at scale? And then, what does good look like? How can we make that the default? And then how do we train developers to use the safe pattern? And then use tools, it could be Semgrep or any tool, to enforce the safe pattern. So from like a 30,000 foot view, this is the approach. So there's lots of criteria you could use. I'm not going to go through these, but here's some sort of heuristics that can be useful. Where do you find the vulnerabilities to work on? Well, if you have a good vulnerability management program, you can do that. Ideally, you have like a list of vulnerabilities you can review to try to target. This is coming from your issue trackers or maybe your commits, or if you have security tools or pen test reports. And then basically you're going to look at those for trends, like does the vulnerable code look similar? And then ideally you're like, okay, what's like a widespread issue that's high risk that we can target? I include this to point out that there's a lot of different approaches. We're going to focus on just lightweight static analysis because it's like too much to talk about everything, but that's not always the best approach depending on what you're targeting. So what safe patterns should you use? Obviously, I'm a big fan of OWASP. So there's some cheat sheets in the ASVS project, making it the default. So there's like probably an internal coding docs and different things like that. And the developer productivity team, I think, is a nice insertion point. So training developers to use the pattern, you need to communicate like, hey, this is what I want you to do. You can't just sort of expect them to know what's in your head. And then finally, enforcing the tools. So yeah, I'll probably in the future talk about this in more detail, but I just wanted to give you like a brief overview. So let's say you bought into the secure defaults and you're like, this sounds great, but it's a big, heavy lift. So we're trying to make that easier for you. So we've been chatting with the project leads for OWASP ASVS and the OWASP cheat sheets projects. And our goal is to have basically out-of-the-box support for checking, is my code compliant with ASVS level 1? And can I find code in CI as well as in the IDE that violates cheat sheets best practices? So shout out to some of these people, but this is early stages, but I think it's pretty promising. And what we've done with these XSS and insecure transport rule sets is saying like, okay, what are all the ways to, for example, like disable output encoding? And then let's like flag all of those. So we're not saying that this is definitely exploitable, but we are saying that you are potentially, there's a foot gun opportunity here. So maybe you want to either manually audit it or fix it. And similarly with this insecure transport rule pack, we're like, what are all the ways to disable TLS certificate verification? What are the ways to talk over HTTP and not HTTPS? And we basically bundled all of those so that you can just immediately roll these out. You don't have to do like a ton of upfront work. You do have to do probably a burn down of these issues over time. But we've ideally done the hard work for you. So we actually haven't talked about this publicly too much yet, so I'm excited to share it with you now. So we've created some XSS prevention cheat sheets for Django, Flask, Java, and Rails to say like basically what are all the ways to shoot yourself in the foot. So for example, it's like, well, if you use MarkSafe, you're turning off the protections. If you use safe string and so forth. And then at the bottom here, we have like, basically, if you're like a security engineer, here's probably the things you should look for. Like you could ban this function, you could ban this other thing, and so forth. And so basically everything possible, we've tried to create a corresponding Semgrep rule so that you can say like, these are sort of the secure defaults that we want to enforce, and I'll manually audit any place that that is not the case. So still a work in progress, but I think there's some pretty good coverage already. So yeah, I guess any questions about this? Sorry, this section that I sort of skimmed through is actually like a 50-minute talk in itself, but I wanted to move on to other things. But yeah, any thoughts or questions?
I think that's fantastic. I think it's where we need to get to as a profession. Like somebody comes out with a vulnerability. I remember like operationally for detection, people would say, "Oh, here's a like a snort rule to detect that." Like if we can get into the habit of, "Oh, there's this bad thing that you're supposed to do. Here's a Semgrep rule to do it," and then basically build that library over time, so that you can actually start applying them and not have to read a bunch of papers or whatever to try to figure it out.
Yeah, that's a great point. Yeah, see you, Petra. But yeah, the goal, and we've actually been working with some framework maintainers like Jacob Kaplan-Moss, who is the Django co-creator. And let's see. Yeah, so we actually, and yeah, you can sort of like see all like these specific checks, like what exactly we're looking for if you want. Oh yeah, I'll share that. But yeah, so I think our goal is like, for the people who know the frameworks the best, for the people who are domain experts in all these things, like just codify that knowledge and sort of make it available for the community so that we can all benefit. For example, like you may be an expert in Rails, but you're managing a massive team, and your company, like one of the development teams adds like Spring or Express.js, and you're like, well, I'm not an expert in that. But if we have this, again, sort of like open source community of like domain knowledge that anyone can apply for free on whatever they want, then that would be good. So yeah, that's the vision. Let's see, so Nilesh asked about sharing the Semgrep CI docs. So yeah, if you just go to docs and then search CI, you will find it, but I will also post it here. Yeah, so yeah, let's just finish this up strong. Yeah, so basically we have best support for GitHub and GitLab right now, but really any pipeline where you can run a command line tool or Docker, it'll work. So if you're curious, we've been talking about like the CLI so far. We also have like something we call Semgrep agent, which adds in some additional useful stuff. It's like diff aware, plays nicely with various code hostings, etc. Oh yeah, and just to be like totally transparent, this is sort of how I mentally model us compared to other players. And we do have this sort of like SaaS app that is useful for like managing scanning at scale. And that is not open source because that is our business model. That's how we're trying to make money. And you don't need to use it. You can use everything I've talked about. And you can use Semgrep and CI without using this. It's more just like a value add. It's not a hard requirement by any means. But the idea is like, okay, can we basically like, we observed customers who were rolling out Semgrep to hundreds or thousands of repos. And there were some problems that they kept having, like, well, how do I set my scan policy across all these repos? How do I review the results? And I want to see trends and metrics and dashboards and sort of like the enterprisey stuff. So that's basically what we're building into this. But the tool and the rules and integrating into CI is all like open source. You can do whatever you want. You don't need to talk to us. Yeah, so let's do a quick example of rolling it out to CI. So basically what we're going to head to is we're going to write a custom check to find unauthenticated routes. And we're going to set it up so that we will automatically comment on that pull request with a suggested autofix to say, hey, looks like you're not doing this. Please do this. Yeah, and I think for time's sake, I might just sort of do it myself and we can sort of walk through it together. But yeah, I guess yeah, if you want to.
Yeah, people can do it in their own time as well, offline after the session.
Yeah, that's a good point. Yeah, so let me just show you how this works. Or I guess let me quickly ask, who would like me to sort of walk through this process? It'll take maybe like 5 to 7 minutes, or we could focus on something else. It's up to you.
Jason is up for it. I do think it has been around more than 2 hours, and we know the attention span of people is much less than that. And I am serious of having another session in January, and instead of rushing it now, we could put it great attention, give it the attention that it deserves. What do you think?
Cool. Yeah, how about yeah, maybe we can do something in January that's more focused on like just a sub part of the things we covered today. Maybe just the part that I sort of went quickly through, and then maybe CI. But since some people are still here, I could do CI now and then just like stay around for questions.
I'm up for both.
Sorry, you proposed both?
I'm up for both.
So, all right, so yeah, I'm going to do a quick CI example now, and we'll potentially do a longer, or not a longer, but just a separate session in January focusing on CI as well as sort of targeting vulnerability classes in general. Okay, so yeah, let's walk through this. So again, basically what we're going to do is we're going to onboard a repo to do continuous scanning with Semgrep. We're going to write a custom rule that's specific to the code base we're examining. And then we're going to show how that we can auto-suggest a fix. So big picture, that's what we're going to do in the next 5 to 7 minutes. So here is a repo. This is just forked from a vulnerable Flask app that Weave45 created. And let's see how we can add this to Semgrep. So if we go to semgrep.dev/manage, this is sort of Semgrep community, which is our SaaS app. So this is free to use. There is like an enterprise and sort of Teams version with some additional features, but this is free for you to use on open source or even your company's code up to a certain point. I think there's some, like, if you want private rules or very advanced like config management, there's like some other stuff. But basically, if you want to do this right now, you can do this for free without talking to me. OK, so basically, we're going to set up a new project. So we're going to create a token, which we are going to give Semgrep, and that's how Semgrep is gonna reach out to our server and say, oh, what rules do you want me to run? And then it's going to fetch the rules so that you can sort of centrally manage what you're running rather than having to do a pull request to all the repos if you want to change what's running where later. OK, so let's see, how is that going to look? So basically on this repo, you could do this org level, or in this example, it's just one repo, so we can do that. We're going to say, OK, go to the secrets for this repo, create a new one. We're going to copy in this secret name and value, then add secret. And this is just using the sort of built-in stuff that GitHub provides. It's not anything sort of fancy. OK, so basically this is just saying, hey, Semgrep is going to report some meta information about what's scanned to this SaaS app. It's just going to report the findings. It's not leaking source code or anything like that. We don't want to steal anyone's source code because that's just liability for us. We want as little data of yours as possible. OK, so now we are going to set up a GitHub action so that whenever there's a new pull request, Semgrep will run. So how do we do that? Well, there's a specific GitHub workflows folder. And so we are going to, probably realistically, you would do this like command line, but it's just nice to do it in the UI for demo purposes. OK, so we're going to create a semgrep.yaml file. Just copy in the text here. So this is just using the GitHub action syntax. So we're saying, run this semgrep job. This is the Docker image to use. Pass in that secret that we passed, that we set up a second ago. Let's see. So because this is a demo, let's YOLO swag commit to master. OK, cool. We've got Semgrep, the GitHub action set up. So OK. So the next step is just creating like an example new file and new pull request just to make sure that Semgrep is working. So let's just create a new file. And this is just an example. Like, it can be whatever you want. This is just sort of like the simplest minimal thing that you could do. So we're going to create a new Python file and say 5 is equal to 5. There's a Semgrep rule that just says, oh, if you see something like this, it's probably wrong. So again, this is just an example. Anything Semgrep will flag would work fine for this. We're just trying to prove to ourselves that Semgrep is actually running. So we'll create a new branch and create a pull request. And because we set up the GitHub action a second ago, it's going to say, oh, hey, new pull request. Let's run Semgrep. And then if you remember the message field in the metadata tag for the rule that we were looking at a minute ago, the text of that is actually going to be commented in the pull request here. Like on the code, say, hey, this line, this is what we found. So yeah, if we wait another second. And if you actually look at the details, what you'll find is the time it takes for the GitHub action to like pull the image and then run it is actually sort of the majority of the time spent here. But looks like we just finished. So the scan failed because we found this issue and we commented, hey, this is always true. We're using a meta variable to say, oh, we can actually include the exact value and so forth. So, OK, cool. This is an example of going from Semgrep not in CI to scanning every pull request in like 3 or 4 minutes. But I think we can do a more interesting example. So we can finish. If we go back here, we can see, hey, we just scanned this a few seconds ago. We have one finding. So one thing that's interesting is Semgrep SaaS supports a bunch of policies. And what a policy is basically one or more rule sets that we want to scan our repos. So rather than having to manage those in every repo, you can manage, say, hundreds or thousands of repos, what gets scanned where, in one place. So you could say, oh, I want all my Flask apps to get this policy. I want all of my Android apps to get this policy. And you can actually change these behind the scenes sort of whenever you want without talking to the dev teams, because you're essentially managing it here. So for each rule set, you can say, do you want to notify me? Do you want to block CI? Yes or no? Because sometimes you might want to say, oh, I want to see when anyone adds a route, but I don't want it to block CI because that's not necessarily a security issue. We have like a findings dashboard. So this is like still pretty new, to be honest. We're still figuring out what exactly we wanted to do, but we're showing things like, hey, how many things are we finding? Are developers fixing it or not? Which policies are performing well? Like what is finding issues? Like just sort of like stuff like that. For notifications, you can do like Slack hooks, web hooks, and so forth. So, but the thing I wanted to show you is, let's see. So in this application, because of how it works, basically in every route, there is a check for the authorization header. It tries to pull a JWT token out of that. And if that JWT token is not present, it just returns error. So this is a very interesting application-specific business logic thing that we would like to enforce. So no static analysis tool out of the box is going to understand how your code base works because they've never seen it before, right? But I just wanted to show like this is a way that you could like codify something that's unique to you and then roll it out in CI. So one thing, we're actually going to sort of abuse GitHub's suggestion feature. So in the message, we're going to use the suggestion syntax to say, hey, if you find this route that does not do an authorization check, flag it, and then comment on that pull request this snippet, which is basically going to use the meta variables that we match in the pattern to suggest an auto fix. And one thing that's pretty cool here is see this add to policy button. Basically, like if you were to say, my custom business logic, and you were to save this, so you could prototype a pattern and then click add to policy here, and then directly add it to one of the policies you're using to scan repos. So if we click that, and then if we were to go back to here, we can see that that custom rule that we just wrote in semgrep.live is like already running in whatever policy you wanted to. So this is a great way for like, oh, you have a bug bounty submission, or oh, you just found a bug. You can like prototype a rule for it and then roll it out into CI in like, as long as it takes you to write the rule, because once it's written, you can just deploy it with like one click, basically. So I'm going to delete this because it's actually already added. But just to show you what this looks like, we've got lots of tabs. No, not that one. Okay, so let's just take the test code we have here. So these are like the example vulnerable code snippets that we want to find. And let's just go back to this repo. And let's add this purposely vulnerable code to this routes file just to see like, does our rule behave as we would expect? So just copy this routes that do not require authorization in there. No auth. We will create a pull request. And then, yeah, let's just let it run. So I think what is interesting here, and I want to show you, I'm not going to like talk through it, but on our blog. So this is actually, I think, a pretty interesting use case for self-service security. So one of our engineers, Nathan, basically the story behind this is he was like, we had some logging in our code that was like accidentally logging some sensitive information, and he found this issue and then was like, oh, we shouldn't do this. He then went to like semgrep.live, wrote a custom rule to say, okay, this is what it looks like for us to log sensitive information. So he found the bug, wrote a rule, and then he added it to our CI checks so that anyone writing code and pushing it to our SaaS app is not going to do that same mistake again. And he actually did that without talking to the AppSec team, and just found the issue, wrote a rule, deployed it all himself in a couple of hours. So I think that that's pretty cool. Okay, so our pull request has finished. So we have matched, this route was not doing an authorization check. This is the text from the message in the rule. And the developer could say like, oh, I want to merge in this change. So again, we're just trying to make it as easy as possible for developers to do the right thing without sort of giving them something security related they need to fix and then not giving them much guidance on how to do so. So again, AutoFix is early stages. There's a lot of stuff we want to build, but I think it's an exciting direction. So yeah, I think that's adding to CI. So we went from not in CI to adding an initial policy, and then we wrote a custom rule and then deployed that to run on every PR in about 10 or 15 minutes. So yeah, there's a bunch of other stuff I could talk about, but I would rather just answer questions. So yeah, let me know what you think.
Very cool. One thing I wonder about is, does it support the multi-line change suggestions? If you wanted to denote something, you want to replace more than just line 50 through 59 or something.
Yeah. Yeah, so there are, yeah, so there is actually a fix metadata key that you can use in Semgrep rules. This is actually sort of abusing the message key to do that. So like that is to say there is like basic support for this, but there is like a ton that is could be made better. In terms of like fixing multi-lines, yeah, that's definitely something that we can and will do soon. There is actually ways in Semgrep, and this is very new as of like last week or so, that you can use a meta variable to match like multiple lines or multiple statements, such then you could then replace like a whole section or like bits and pieces if you're doing like an autofix type thing. So my answer is yes, but it's early stages for that. But if you have a specific use case, we would love to hear it, because then we can build something that does that.
Cool. Awesome.
Yeah, good question.
Please join our Slack, guys. There you can ask questions to Clint, as well as the community as well. I have pasted the link into the chat.
Yeah, and yeah, definitely join their Slack. If you have like Semgrep specific questions, we also have a community Slack as well, and you can see like people are always asking questions and getting help from us as well as from people in the community about how, yeah, it is linked there. But
I definitely wanted to thank you for the talk today and give you some feedback that I think you really hit the sweet spot here.
Thank you.
I've used a lot of various types of things like this, from lint to find sec bugs to, fortify and check marks and all these other things. And I think that this is something where I can actually not only teach AppSec engineers how to use, but I think we could actually teach developers how to do this, which I think is amazing, right? I mean, it's like because, you know, teaching even AppSec engineers like how to write a correct regular expression, you know, gets to be a little complicated sometimes. Especially if you're talking about all those nuances of like not including, you know, the bazillion false positives. So I think this is really excellent. I think you've nailed it. Really glad to see this.
Yeah, thank you so much. Yeah, our goal is we don't want this to be a security tool. We want it to be a tool for everyone who wants to search and find code. And yeah, we have actually given presentations to like AppSec teams, and then they've said, hey, can you actually, you know, present to like my engineering productivity team, the people responsible for ensuring code quality across like, you know, our massive org. So yeah.
Right. I mean, I started looking at like CodeQL, and I thought that was a little bit too complex for most people. So I think this really hits the spot.
I think CodeQL is, I think, great and very powerful, but I think at least in my opinion, the barrier to entry is too high.
Yeah,
for many.
that's what I'm talking about. Exactly.
Yeah,
and part of the problem with that is like, you know, people whose job is to do like to write rules and stuff, you know, it would be not a barrier to them because that's their job. But I think that, like I said, you know, when we want to, if we're like, I'm like an OWASP, right? I'm like, my job is an AppSec person. And I think the only way to move the bar with that is basically to be able to put this type of stuff in the hands of developers. We can't rely on AppSec experts, right? We have to shift left. And so I think you've done exactly that.
Well, thank you. Yeah, it's many smart people working on it. I'm just one person. But yeah, I'm excited by the direction, and I'm glad you think so too. So thank you.
One use case I've heard from developers is people that are maintaining shared libraries internally are interested in finding out who's using their library and maybe even which version. I imagine that it would be relatively simple to write, you know, rules that could check everybody's code and be able to gather that information in one place so somebody could see.
Yeah, that's a very interesting use case. We're not really talking about this publicly too much yet, but you know, we're all friends and family here. We are working on some sort of initial prototypes for like, can Semgrep be used to like just understand the purpose of code, or like just what is in it? Like, is this like a web app? Is this a front end? What libraries does it use? What does it use them for? More like a code understandability thing than just specifically security. There are security applications, but yeah, that could be used for like, you know, a VP of engineering to understand, you know, what tech stack they're responsible for, and things like that. So early stages, you'll probably see something about that from us next year, I would guess. But if you want early access, let me know.
Any more questions? Okay. Thank you all for joining us, and thank you, Clint, for this very elaborative presentation and hands-on exercises. It's been great. Most of us learned a lot of things, and we will continue this in January. And thank you again, everybody.
Yeah, look forward to it. Thanks a lot, Clint.
Thanks so much. Thanks for coming.
Thank you.
All right, take care. Have a good day.